Okay, this is the 5 for 5 that was due today, or last night at 11:59. I did grade it for accuracy. It was kind of disappointing because I could tell a lot of people did it at the very end and didn't put a lot of time into it. So the biggest thing here is making sure that you read the information. This is the graph of f prime. And a lot of you interpreted this to be the graph of f, I think because we rushed through it. In AB1, it says find all values in the open interval from -3 to 8 for which the graph has a horizontal tangent line. Well, since this is f prime, we all know that that's where the slope equals 0. And I think I saw a lot of that. That was a very positive thing. But because this is the graph of f prime, it's not going to be here where it has a horizontal tangent, or here, or even maybe here. It's going to be where f prime is 0. So at -3, +1, +6. That's where you're going to have a horizontal tangent. Now it also says, for each value of x, determine whether f has a relative minimum, maximum, or neither. Now -3 you couldn't tell. You just didn't have that knowledge about whether or not it was going to be positive to the left or negative to the left or whatever. So -3, not enough information. For x equals 1, here the slope is positive. Here the slope is negative. So positive to negative is a relative max. For x equals 6, it does the reverse. It goes from below the x-axis to above the x-axis. So that's negative to positive, and that's a relative min. So that's what number 1 needed to say. For AB2, it said find the minimum value of f on the closed interval from -3 to 8. I got a lot of this. X equals 6. Guys, that's just flat out a wrong answer. Even if that is where the relative minimum occurs, that's not what they're asking for. They want to know, and let me be very clear here about the words. Find the minimum value of f means to find the y value. And we've had this discussion before. It came up on a test. It was in Delta Math, and everybody got really upset. But these are AP words. When it says find the minimum value of f, that means they want the y value. They want to know what that y value is of that low point. Now, when they're asking for the minimum value, or the minimum of f, they're talking about an absolute minimum. So I'm going to cross that out. If they mean relative, they're going to say relative. And in this case, you have to use the candidates test. You have to test the critical points, which would be x equals 1 and x equals 6. And you also have to test the endpoints, which are -3 and 8. That's an absolute requirement for finding an absolute min or max. So I believe, let's see here, they gave us, they gave us f of 1. They told us that f of 1 was -2. So that is a potential for the minimum. Now what I had to do for the other three was I had to do something along these lines. I had to test -3. And in doing so, I had to integrate from -3 to 1 of f prime of x dx and use the fundamental theorem of calculus. Now, why did I choose 1? Because I knew what 1 was. I knew what f of 1 was. That's -2. I know what this is because I can get this from the graph. So if I look from -3 to 1, that area is 10. And then this would be our variable, what we're searching for. So when we add 2 to both sides, we'll get 12 equals -f of -3, and f of -3 equals -12. So that's a better candidate for an absolute minimum than this one. Now I'm going to test 6 in much the same way, but I'm going to go from 1 to 6 this time. Why is that? Because I know the area from 1 to 6. Okay. So that area is, they say, is 14, but remember it's below the x-axis. I know f of 1 is -2. I do not know f of 6. That's what I want to know. And I know the area between the x-axis and that curve is going to be -14. So in this right-hand side, this is going to become a +2. And f of 6 is -16. That's an even better candidate. So I'm going to test 8 and see if that works out any better. And yes, you do have to go through this process for all of the candidates, the endpoints and the critical points. So now we'll test x equals 8. We're going to go from 1 to 8 since I know what 1 is. I guess I could go from 6 to 8. But the problem here, I believe, is with the graph. Yeah, I do. I could do 6 to 8 here. So I could do the integral from 6 to 8 because I know that area is 6. Let's do that. Might be a little calmer. So that would be f of 8 minus f of 6. That area they gave us to be 6. We don't know f of 8. We know f of 6 from the last part, -16. And then when we subtract 16, we'll get f of 8 is -10. So out of all of those y values, we have a -10, we have a -2, we have a -12, and we have a -16. The -16 is the minimum value of f. Now some of you put f of 6. I took it, but I don't know. Some of you did this. I'm going to put a question mark here. I don't know if the College Board is going to take that. I know they will take this. Okay, so let's take a look at AB3. AB3, here some of you flat out just took the derivative of the numerator and the derivative of the denominator. At no time has that ever been the case unless we're using L'Hopital's. And in which case you would have to establish that it's an indeterminate form, 0 over 0, and we're not taking the limit. So this is not a L'Hopital's problem. So when you do this, you have to use the quotient rule. A lot of you did the quotient rule just fine. So I'm just going to write this out. Low Then we're going to have the derivative of e raised to the g of x, which would have to be chain ruled out, minus the high times the derivative of the low, all over low squared, and then we want h prime of 6. So at that point, it's just a matter of plugging in 6. Now you can't leave it exactly like this because it still has function values in it. It still has a g of 6 and a g prime of 6, but we can get those from the graph. So g of 6, not the graph, the table here. So g of 6 is 0, and g prime of 6 is 1. E to the 0 times 3. And that's how I would leave my answer. On an FRQ, I would not do any more than that. All right. For AB4, let me scroll down, show you AB4. AB4 says, is there a time C where C is between 1 and 9 on that open interval, such that g prime of C equals -1/2, and give a reason for your answer? The answer is very simple. The answer is yes, because it is twice differentiable. Right here. That means that it's also continuous. And so the mean value theorem guarantees this. Let me put AB4 here. The mean value theorem guarantees it if the function is continuous on the open interval and differentiable no, it's the other way around. Continuous on the closed and differentiable on the open. So I always remember this acronym, CCDO. Continuous on the closed interval, differentiable on the open. Now, if it's twice differentiable, then it's automatically going to be continuous. But you have to say that. And some of you said that really quite well, but others forgot about the mean value theorem. AB5, let me write that down, from 1 to 4. People had trouble with this one. The clue here is that you can't multiply these. We learned properties of integration with addition and subtraction. But the only way that we can do it with multiplication or division is with, at this point, with what you guys know is U substitution. And I recognize the U substitution because I have a G and I have its derivative. So if I were to let U be G of X, then the derivative of U would be G prime of X dx. Well, I have that. That part would be my du. G of x being my u would make that u squared. And I would have to change these bounds. I would have to take the 1 and plug it in here. So for x equals 1, u equals g of 1. And from the table, g of 1 is 3. So this would be from 3. And then for x equals 4, u equals g of 4. Let's see, g of 4 is 1. Now, another way that you can do this is you can go ahead and just integrate the U, but then before you evaluate it, you can go ahead and substitute the U back in. And then you can evaluate it at your original bounds of integration. Some people like to go through this process. If it's an FRQ, the College Board expects to see it. But this is still legal to do that after you substitute the U back in, or what you had for U. You can go ahead and do that. And that's how I was taught to do it. So this would be G of 4 cubed over 3 minus G of 1 cubed over 3. And what you would be doing here, if you evaluated this from 3 to 1, you know, you would just have similar outcome. So G of 4 is 1. G of 1 is 3. So you'd have 1 cubed minus 27 cubed, or 1 cubed over 3 minus 3 cubed over 3, excuse me, is negative 26 thirds. So that's how that looks. I just wanted to give you guys a little explanation because our class time is so limited with regard to going over this. I did grade it for accuracy because I expect you guys to spend a little bit more time working on it than what I saw in the homework. Thanks, guys. Have a good day.